Ever wondered how blockchain maintains its security and efficiency? Today we dive into one of its core components, the Merkle tree. At its most basic, a Merkle tree, named after the computer scientist Ralph Merkle, is a hierarchical data structure. It's a bit like a family tree, but for data. This tree is made up of cryptographic hash values, a fancy term for a kind of digital fingerprint. Creating a Merkle tree is like pairing off these data fingerprints, known as leaves, and hashing them together. This process is repeated, pairing off the hashed pairs until we're left with a single hash. This hash is known as the root hash. Just as a tree's root supports the entire structure, the root hash represents all the data contained within the Merkle tree. Any changes to the data, no matter how small, will result in a completely different root hash, serving as a tamper-evident mechanism. Now that we understand what a Merkle tree is, let's uncover its role in blockchain. Merkle trees play a significant role in blockchain technology, serving as the backbone of data verification and scalability. Their primary function is to ensure data integrity and to facilitate efficient verification of large data sets. But how exactly do they do that? Let's delve in. Imagine a blockchain network where nodes need to verify every single transaction within a block. That's a considerable amount of data to process, right? This is where Merkle trees come into play. Instead of verifying the whole block, nodes can simply compare the Merkle path of a specific transaction to the Merkle root of the block. Think of it like a massive library. You don't need to go through every book on the shelf to find the one you need. Instead, you use the library's catalog system, which directs you right to the book's location. Similarly, Merkle trees provide a catalog system for transactions within a block, making data verification a breeze. Now, let's take a real-world example. In Bitcoin, each block contains a Merkle root that represents all transactions within that block. When a node needs to verify a specific transaction, it doesn't need to sift through the entire block. It simply compares the transaction's Merkle path to the block's Merkle root. If they match, the transaction is verified, all without the need to access every single transaction within the block. But that's not all. Merkle trees also play a crucial role in blockchain scalability. By condensing vast amounts of data into a compact Merkle root, blockchain systems can manage and verify huge amounts of data efficiently. This ensures that as the blockchain grows, the system remains secure and performant. So in essence, Merkle trees streamline data verification and enhance scalability in blockchain networks, making them an indispensable part of blockchain technology. By comparing a transaction's Merkle path to the Merkle root hash, nodes can quickly verify the inclusion of the transaction without needing to access the entire block. So why should you care about Merkle trees? Well, if you're intrigued by the world of blockchain technology, Merkle trees are a concept you simply can't afford to ignore. They play a vital role in the functionality, security, and efficiency of blockchain networks. Let's consider scalability, a crucial aspect in the ever-growing blockchain environment. As more and more transactions occur, it's essential that our systems can accommodate this expansion. That's where Merkle trees step in. By aggregating large amounts of data into compact Merkle roots, blockchain networks can handle vast amounts of data with impressive efficiency. This is possible due to the hierarchical structure of Merkle trees, where each level up represents a summary of the information below it. This compactness doesn't come at the expense of security or performance. Quite the contrary, it enhances them. With Merkle trees, you don't need to check every single piece of data to confirm its integrity. Instead, you can verify specific transactions by comparing their corresponding Merkle tree paths. This feature saves time and computational resources, making the verification process much faster and more efficient. Moreover, Merkle trees add a layer of tamper evidence to the blockchain. Any slight change in the underlying data results in a completely different root hash. This means, if someone tries to alter a transaction, it becomes immediately evident. This tamper-evident mechanism is a cornerstone of trust and security in blockchain networks. So you see, understanding Merkle trees isn't just useful, it's essential. Whether you're processing transactions, validating blocks, or auditing data integrity, Merkle trees are your key to navigating the complexities of blockchain technology. They provide a way to maintain security while enhancing performance and scalability, ensuring the blockchain's potential can continue to expand and evolve. Whether you're processing transactions, validating blocks, or auditing data integrity, understanding Merkle trees is essential for navigating the complexities of blockchain technology. So that's it for our exploration on Merkle trees and their role in blockchain. We've delved into the world of cryptographic hash values, understanding how they form the backbone of blockchain's security and efficiency. We've seen how Merkle trees streamline data verification and contribute to the scalability of blockchain networks. It's clear that mastering Merkle trees is a step towards demystifying the intricacies of blockchain technology. Thanks for watching. Don't forget to like, share, and subscribe for more educational content on blockchain technology. Until next time, keep exploring, keep learning, and keep innovating. Goodbye.